the two-dimensional domain z square such that P is equal to x plus b. That is a vector addition where x belongs to x and b belongs to b, where b is the structuring element and capital X is the image. And it is also, it has one more definition, that is x dilation b is equal to the set of points p such that the structuring element is reflected, then it is translated by the vector p. Intersection of that with respect to the image should not be a null, then only it will be in x dilation b. It should not be null. Okay, so this is the definition of dilation. So both definitions will give you the identical results. Then application of dilation, we have seen it is actually used to remove the internal noise present in the image. So we had noise, I have given this example. So you can fill this noises using the structuring element. So here we have used 3x3 structuring element, right? So the output what we got is these internal noises are filled, means they became, initially they were in the background, now they became foreground. But the drawback is, a drawback of dilation, it extends the boundary. Okay, it extends the boundary by 1 pixel length in this example for this structuring element. Next, the second important operation in morphological image processing is called as erosion. Okay, now here also x is the image and b is the structuring element. So x erosion b, it is shown by a negative symbol surrounded by a circle. It is it's actually removing something. Okay, so x erosion b is equal to, definition is very important, a set of points p which belongs to the two-dimensional space z square such that p plus b for every p plus b which should belong to x for every b belong to b. That means you have set of points which are in the two-dimensional spatial domain such that you have to add all these points in the set P to the points of structuring element B. So when you add this P plus B, it should be there in the image set X. Okay, that is the condition. But you have to do this addition for every B belonging to capital B. Capital B is a structuring element. So for every B, you have to add the value to the point set P in such a way that the P plus B should be in the image set X. So this is the meaning. So if you understand this, then we can work out the problem. As similar to the dilation, you have one more definition for erosion. That is x erosion B is equal to set of points P such that you have B is the structuring element. When the B is translated by this vector P, which should be the subset of X. So if it is a subset of X, then it will be there in the set X erosion B. So I hope you understood both the definitions of erosion. So I repeat the definition of erosion. First definition, you have a set of points which are in the two-dimensional space such that you add each point P to each point of the structuring element. When you add it, which should be there in the image set X, and this addition should take place for every B belonging to the structuring element capital B. So this is the definition. So now we will work out one problem on this. Okay, so let us take one image. Okay, so I will please copy this image and we will find out the erosion. Okay, so take 6 columns, 2, 3, 4, 5, say 6 columns and 6 rows. 1, 2, 3, 4, 5, say 6. Okay, Now this is an image, say let me take it as x. Okay, we have the foreground pixels I have shaded here. We have foreground pixels like this. So these are our foreground pixels. Remaining ones are the background pixels. Okay, and let us take this as the center. Okay, center or the origin. So 0, 1, 2, 3, 4, 5, 6. This will be 0, 1, 2, 3, 4, 5, 6. Okay, and let me take the structuring element. Okay, 3 cross 3 structuring element. So no, sorry, 4 cross 4 we will take. Okay, 1. So this is a structuring element and take it as B. Okay, and the structuring element has on shaded at the center only, center row. Okay, and let us take this point as the origin. Okay, origin. So this will be 0, this will be minus 1, this will be plus 1. So this is minus 1, 0, 1. Okay, so this is a structuring element. Now my question is, you have to find out x erosion B. So please try this problem. So what is the definition, you know, right? So we have P, set of points P, which is in the two-dimensional space, right? Belongs to, sorry, belongs to Z square, such that every P which is added to B should be in the set X for every B belonging to capital B. So this is a definition. So use the definition and please give me the answer. We'll give you 2 to 3 minutes. I hope all are working. Please work out the problem. Apeksha, are you there? Apeksha, please try the problem. Okay, everybody, it is not only for Apeksha. Please, Prajwal, Anil, Divyashri, Gashmit, I can see here. Please work out the problem. What is the answer? You know the definition now. Okay, so now here I will explain this, how to do this. So let us take this point. Okay, this point. So now when you take this point has to be, you know, as per the definition, it is P plus B, right? So can you tell me what is a B? Set B. B is having how many points? We have minus 1, 0. Then we have the next element 0, 0. The third element in the set B is 1, 0, correct? 1, 0. So this is our B. Now we have to add. Now for example, if I consider this as the point P, okay, then when this P is added, because it is P plus B, right? P plus P. So when this coordinates are added to this minus 1, 0, this is 0. So where this point will be shifted? Anybody? Can you tell me? Prajwal, where it will be shifted? When I take this as P, okay, what is the coordinate of this point? It is 3 comma 4, right? 3 comma 4. So when I add 3 comma 4 with minus 1 comma 0, where the point will be shifted? Minus 1, 0. This is P, this is B. Prajwal? 2 comma 4. So 2 comma 4 means it will be shifted where? Here, right? 2 comma 4 it will be shifted. And what is the condition says, when you add it, which should also that added whenever it is shifted, it should be present in X. So it is present in X, right? So that condition is true, but you have to do it for every B belonging to capital B. Now let me take the same point, that is same point X, and 0 0 it will be in the same column itself, there is no difference. Now and when I add the next B value, that is 1 comma 0, can you tell me the coordinates? What is the coordinate? Divyashree, can you tell me the coordinates? When I add the next point, next B point, coordinates will be 4 comma 0, right? So 4 comma not 4 comma 0, sorry, it will be 4 comma 4, right? Na 4 comma 4. So where it will be shifted? Point will be shifted here, but this point is not present in the image set X, right? So P plus B belonging to X, okay, it should satisfy for every B. Since it is not satisfying for one B, that is 1 comma 0, if this particular point is not a member of X erosion B. So this is not the member, right? So similarly, if you check the other points, because this also will be, when it is added with 1 0, it will be shifted here. So this point is not the member of X. So we cannot consider this point. This point won't be present in X erosion B. Similarly, this point also not, it's also not there, and this point is also not present in X erosion B. So this column completely will be removed from the output X erosion B. Okay. Similarly, if you check, what about the center one? Center one, Carlton, are you there? Center one, whether it is present in X erosion B? Second column. Second column, if you consider this, what is the for the first point, what is the coordinate value? It is 2 comma 4, right? So when you add minus 1 0 to this, okay, so it will become 1 comma 4. So 1 comma, right now I'm right? Yes, 1 comma 4 is this point, which is already there in the set X. So, and if I add 1 comma 0 to this, it will become 3 comma 4. Again, 3 comma 4 is also present in the set X. So these all points will be present in which set? Will be present in the X erosion B. So this point is there, this point is there, this point is there, and even this point is also there. So what about this? When these points, when it is added with minus 1 comma 0, they will be shifted here. But these points are not the member of X, image X. So you cannot have these pixels in your X erosion B. So now X erosion B will have only the center column, that is this point, this point, this point, this point. So in terms of point set, I can write it as X erosion B. The answer is, can you tell me the answer? 2 comma 4, then 2 comma 3, 2 comma 2, 2 comma 1 are the members of X erosion B. Means it is removed, the first column and the third column are not there in X erosion B. So is it clear? Is it clear? If it is clear, please put it in the chat box saying that it is it's clear. Okay. I will give you one more problem on erosion. Yes, obvious. Yeah. Okay. Okay. So this is about, thank you. It's about erosion. So the same problem, it's there here. So you get only the center column. Okay. Now please take one more problem on erosion. Okay. So you have an image like this. Please copy this image. Okay. So take this image as X. Okay. And you have the structuring element B, which is 3 cross 3, and all the elements are shaded, and this is the center pixel or the original pixel. Okay, and the foreground is this. Okay, this is the foreground which is shaded in dark blue color. Okay, you have these points and again 2 points here, and here two more points. So these are actually the due to noise these are added. Actually they were supposed to be the background, but due to noise they became foreground. So you have to remove this using the erosion operation. So can you try this and tell me what is the result you're going to get? So here for the image X, you take this as the origin. So this will be 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2, 3, 4, 5, 6, 7. Okay, here this is the origin. So 0, this will be -1, this will be +1, -1, 0, 1. Okay, so this is actually the foreground. Okay, foreground, and these are the noisy points. Okay, so these noise pixels we have to remove it use by performing erosion operation. So what is the answer for this? So please find X erosion B. Anybody got the answer from B section? Ralston, Ralston D'Souza. Ananya Devadiga got the answer. Sanket?
I'm solving, ma'am.
Solving, okay. You just tell me which all elements are present in the eroded output. Anyone can answer if you get the output. Sharanya, Sharanya P. Astrid, Astrid, are you there? Yeah, you got the answer? Two. Tell me 2 comma 3 is present, you are telling? Ah, ah. It is not only minus 1 comma 1 now. Your B is big. It is not only having 3 elements, it has 9 elements here. Yeah, minus 1 comma 1 is the first element, for example, and the second one is minus 1 comma 0, minus 1 comma minus 1. Then the next element is 0 comma minus 1, 0 comma 0, 0 comma 1, and you have elements like 1 comma minus 1, then 1 comma 0, then 1 comma 1. So you have totally 9 elements in this example. Okay, so when there are 9 elements, then I don't think that point will be there. Yeah, it won't be there, right? So if you check it, this element won't be there because you know, right, it is in boundary. So when it is added with this point, it will be shifted here. So this point won't be there, this point also won't be there, this is also won't be there. So all these first row elements won't be there in the set X erosion B. Okay, similarly, if you see this, these also will be shifted, right, when you add it with minus 1 comma 0, correct? So these, the first column elements are also not the member of X erosion B, and these elements also are not the member of X erosion B, because when these points are added with 1 0, it will be shifted here, but this is not the member of image X. So these points also won't be there in the eroded set. What about this? Anyway, it won't be there because it will be either shifted here or shifted here. But these are actually the background pixel in X, so it won't be there in X erosion B. Okay, what about these points? Can you tell me about these points? This point won't be there because it will be shifted here down when you add it here. So, and again, this point also won't be there. What about this point? Just check this point whether it is a member of X erosion B. So anyway, this is the member of X. Yeah, this is a member of X erosion B. This is a member of X erosion B. This is a member of X erosion B. Now just check whether this is a member of X erosion B or not. Yeah, that is actually 2 comma 3, right? It is 2 comma 3. 3, just add and check whether it is there. It is a member of X erosion B. What about this? This anyway won't be there, right? This also will be removed. Yeah, because it will be shifted somewhere here. This will be shifted, which is not the member of X, right? For I am talking about foreground pixels, not the background pixels. So, so now the external noise is removed now. By using erosion, external noise is removed. But what about the boundary? These boundary pixels we wanted actually, because these were belonging to the X image X, but due to erosion, these points were removed. So this is a drawback of erosion. It shrinks the boundary of the image. Now this question is this, whether this is there or not. Please find out. Anyone can tell me? Hitesh? Hitesh? Whether this is present in X erosion B? Yeah, pixel 2 comma 3. 3, yeah. Whether it is present in X erosion B. It is present? Yeah. Yes, okay. So then, so it will have only 1, 2, 3, 4 pixels now, okay? So the your eroded output is only this much, right? your eroded output, you have only this many pixels will be present in the eroded output, but the noise pixels are removed, that is right, but boundary is shrink now here, right? So this is the drawback of erosion. Okay. No, sorry, that pixel is not there in the result. Just check, this pixel won't be there. You have only 1, 2, 3 pixel. Just check it, okay? In the results, I can't find this pixel here. Just add and check. Okay, this is not there. Only these 3 pixels are there. When you add it, I think you can find out. So you have only 3 pixels, but the noise is removed. Okay, so this is about the erosion that you can check. Okay. Then now I have listed the drawbacks of dilation and erosion. So dilation expands the image boundary, right? So if your structuring element is 3 cross 3, okay, if the structuring element is 3 cross 3, then it expands the boundary by 1 pixel width. And erosion reduces the image boundary, or it shrinks the image boundary, and size of the image boundary need to be maintained in image processing. So whenever you do, actually the dilation is used to remove the internal noise, whereas the erosion is used to remove the external noise, but you have to maintain the image boundary. But the drawback of dilation, if you use only dilation, it expands the image boundary, which is actually not necessary. And if you use only erosion, which shrinks the boundary, means you're going to lose some important pixel information. So these are the drawbacks of dilation and erosion. So for that, in order to avoid the drawbacks of dilation and erosion, two more algorithms have been developed, and they are called as morphological opening operation. The another one is morphological closing operation. Okay. So what is morphological opening and what is morphological closing? Both are derived from the dilation and erosion. So I'll give you the definitions here. Morphological closing means first you have to dilate the image. Here image is taken as A, not X. Dilate the image A by the structuring element B. Okay, first you have to do this. Then what you have to do? Then you have to, whatever result you get when you do A dilation B, that result has to be eroded. Okay, so then it is called as closing. Erosion, you have to do it with the same structuring element. You can't change the structuring element. So morphological closing operation is denoted by A with a small dot here. B is a structuring element. So first you have to do A dilation B. Okay, whatever result you get, then that result has to be eroded with the same structuring element. Then that operation is called as morphological closing operation. Is it clear? So first you have to dilate the image with the structuring element. So whatever result you get, then that result has to be eroded with the structuring element B. That is morphological closing. Then what is morphological opening? Morphological opening is, which is denoted by A with a small circle. Here this is a dot and this is a circle. A dot, A circle, small circle B, called as morphological opening operation. So here what we are going to do, first the image has to be eroded with the structuring element B. So whatever result you get here, that result has to be dilated with the structuring element B. Then that operation is called as morphological opening operations. Now, whenever you are asked to remove the internal noise or external noise, then you have to apply the morphological closing and morphological opening operations. Some applications you may require to apply morphological opening first, then morphological closing. In some applications, you may require to first apply morphological closing, then morphological opening. So I'll be giving the examples for that. So let us take this example. Please copy this example. So we will take this as the image A. Okay, it has two sub images. Okay, one is this, one sub image is this, and another image is this. Okay, we can call it as object. Say object x1, and this is the object x2, and this image is interfered by a noise pixel. See, actually these two pixels are supposed to be the foreground, supposed to be white pixel, but because of noise they became background pixel. That means they became black pixels. Okay, and here this is actually, there is no connection. So you can see there is one pixel length which connects the object x1 with object x2, but actually in your original image this is not there. So this is also a noise, and this noise is called as external noise, and these two noise pixels are called as internal noise. Actually these two noise pixels are supposed to be foreground, but due to the noise interference they became background, and these four pixels are supposed to be the background, but due to the noise they became foreground. So, and these noisy pixels are called as the external noise, and these two noisy pixels are called as internal noise. So now what you have to do, you take this example and take this as a center pixel. Okay, take this as a center pixel, and we have the structuring element b, and take this as a center pixel, and apply, first you apply morphological closing to this image. So can you tell me what will be the result? So whenever you use, this is just a trick I'm telling, whenever you use a 3 cross 3 structuring element where the origin is at the center, that means it, whenever you do erosion, it will remove all the border pixels. Okay, all the border pixels it is removing. And whenever you do dilation with this structuring element, then it will add extra one boundary to the pixel. Okay, whenever you go for 3 cross 3 structuring element where the center pixel is at the origin. Okay, so this is the trick. Actually you need not calculate again and again. So by making use of this trick, can you tell me now, when you perform morphological closing, what is the output of morphological closing? So what is the definition of morphological closing? A dot b is equal to what? Tell me. First, what you have to do? A. Please tell me. A. First, what you have to do? Erosion first or dilation first? Erosion or dilation? I have shown you the definition right in the previous slide. First, what you have to do? Dilation. Yes. So you have to dilate A, dilation B. Then you have to, whatever result you get, that has to be eroded with the same structuring element. You can't change the structuring element. So this is erosion. Okay. So can you tell me now what is the result when you perform morphological closing? So first you perform A, dilation B. When you perform, I told you the trick, whenever you use a 3 cross 3 structuring element, one extra pixel boundary is getting expanded by a width of 1 pixel length, right? So now here, so when this pixel will be filled right now, right now, so this noisy pixels will be filled when you go for dilation, and along with that it will expand the boundary. That means you will get this boundary. Dilation will increase the length of the boundary by 1 pixel, because we have used 3 cross 3 here, right? So if you do it using your mathematical set theory, you will get the same answer. So it will dilate, it will expand the boundary by 1 pixel width, right? This also will be there. Yes, I'm not writing properly, please see. All these pixels will be there now. Okay, so our intention, it has removed the, it made these two pixels as foreground only, but it has extended the boundary by 1 pixel width. Okay, so this is about the A, dilation B. Okay, then after that you have to erode it by the same structuring element. So when you erode it, can you tell me the result, what result you're going to get? So this is the first one, A, dilation B. The output of A, dilation B has to be eroded with the structuring element B. Now tell me the results. What will be the final result? Is it boring? Hope it is not boring. All are working. If it is boring, please tell me. I will go a little fast. Gashmita, are you working? Gashmita Shetty. Trying, yeah. Tell me the output now, final output of morphological closing. Melvisha, yeah. Can you tell me the result fast, quick? So this is the result of A dilation B. Now I will delete this. Now you tell me the result of uh, yeah, I have deleted now. Anyway, when you erode it, all these dilated pixels will be removed, right? Correct, na? The dilated pixels will be removed when you do the erosion. Okay, so these will be removed when you erode it. So this external boundary will be removed. So this will be the output. So these two pixels will be now white actually. These two pixels will become foreground. The internal noise is removed now. So these pixels are converted into white. Okay. So these pixels will be converted into foreground pixels. Okay. So now can you tell me what is the drawback of morphological closing then? So this is the result of morphological closing. Now anyone, can you tell me what is the drawback of morphological closing? Muriel Pinto, can you tell me what is the drawback of morphological closing? Yes, Ligina, you are right. External noise is not removed. Exactly. This external noise, I wanted to remove these 4 pixels also, but I couldn't remove these 4 pixels by performing only morphological closing. We could remove the internal noise, but we were unable to remove the external noise. So which is the next method we have to perform now? So after performing morphological closing, if you perform morphological opening, what happens? So can you apply the morphological opening operation on this image now? So what is a morphological opening? Can you tell me? Morphological opening is nothing but A. Tell me, it is A erosion B. Then what you have to do, whatever result you get, that has to be dilated with the same structuring element. So please apply morphological opening on this image. Okay, here these are now converted into foreground, let it be. So apply it and tell me what is the result you are going to get. Please work out and tell me. So you have to find morphological opening. First, you erode the image A with the structuring element B. Then for that result, you apply the dilation with the structuring element B. So what happens when you A erosion B? What happens when you erode it? Which pixels will be removed? Which pixels will be removed? Boundary is element. Exactly right, Astrid. So boundary will be removed, right? So this will be removed, this will be removed. So this will be removed, this will be removed, this will be removed, again this will be removed. So all these pixels will be removed, because whenever you use a 3x3 structuring element with all the elements are 1, and if you take this center 1 as the origin, then the boundary pixels will be removed. So this will be removed, this will be removed. So these all pixels will be removed. Even this also will be removed, right? So this will be removed. So when you apply A erosion B on this image, so these pixels will, wherever I have written X means those pixels are removed. Okay. Then for that result, what you have to do? Morphological closing means then you have to dilate with the same structuring element. So when you dilate with the same structuring element, what happens? Can you tell me which pixels will be removed, which pixels will be added? So when you do the dilation, with the structuring element 3 cross 3, then one extra boundary will be added, right? So when you erode it, these boundary pixels were removed, and now we have, when you erode it, we have only this one, right? Our image is only this one. This is our image now. When you do a erosion V, right? This is the image. Now after that, I am doing dilation with the same structuring element. So when I do the structure dilation, then again these removed boundaries will be added, right? So again this will be added when I do the dilation, because after erosion the result has to be dilated with B, right? So again it will be added here, right? So all the pixels will be added. So this is in your white. I will show you white. So it will be added. So now the boundary is expanded, and anyway this pixel will be there. Sorry. So this pixel is white only. It became foreground. What about this? This anyway won't be there only, because since the so this won't be there. So this will be completely black now, right? This will become, sorry, this will become fully background, right? So here nothing is there. This is background. Okay, there is no connection now. So what about this? When you do the dilation, these pixels will be added. So now what is the result? Can you tell me what will be the result? So if I want to show with the boundary, so this is your image now, right? This is the object which was actually required. Okay, so this is the first object and this is the second object. So by performing morphological closing first, then morphological opening, you are able to remove the internal and external noises present in the image. Is it clear? Is it clear? Is it clear? Nima? Yeah, yes, okay. So this is about, see, it is shown here. This is actually the morphological closing, which I have already explained you. Then these all things, then opening operations. Anyway, I'll be sharing the slides. You can see later. See, this also removed now when you perform morphological opening operation. So now what actually we wanted, we got that same result, because this is the separate object and this is the separate object, which was actually connected due to the noise, and these two pixels were foreground, background because of the noise. Now these two pixels are filled due to the morphological closing operation, and these two pixels are removed because of morphological opening operation. So this is the desired result. Okay, so first perform, in this example you have to perform morphological closing first, followed by morphological opening operation. Okay, so this is about the opening. Opening smoothens the contours, eliminates the protrusions, and closing smoothens the sections of the contours, fuses the narrow breaks and long thin gulfs, eliminates small holes and fills gaps in contours. So these operations are dual to each other. You can even apply, depending upon the application, sometimes you may have to apply opening first then closing, or closing first then opening. Okay, so this is one more example for morphological opening and closing. You have an original image here. So this is a structuring element. So this is a eroded output. Okay, the boundaries are eroded. The boundaries, or you can see here, these things have become thin actually. Then applying opening on using A, you get this image. Then dilate the opened output, you get this image. Then when you close it, you get, this is the output. Okay, so this is one example for opening and closing. Now then one more, the morphological operation, which is called as hit or miss transformation. So this hit or miss transformation, this is actually the Erosion you studied, dilation, then opening, closing, and this is the fifth one. Okay, hit or miss transformation. So this is mainly used to locate. Okay, it is used to locate objects. Okay, objects or object shapes in an image. Object shapes in an image, locate or detect, okay, some objects in an image. We use the transformation called as hit or miss transformation. Now for example, let us take this example. We have an image A, okay, and which has two objects. Say I will take this object as A1, and we have one more object in the image A2. So now the question is, we want to detect the object A2 in the image A, because it has two objects. So you have to find the location of the object A2, or you have to detect the object A2. So for that, we use a morphological transformation which is called as hit or miss transformation. So to develop this hit or miss transformation algorithm, what we required is, so you know now which object you have to detect. Say for example, I want to detect this 3 cross 3 sub image. I want to detect in this big image A. Okay, so what you need to do is, you have to embed the image to be detected. This is 3 cross 3 image, actually embed it by one more layer. Okay, one more layer of pixels. Okay, so this the object to be detected is denoted by X. Okay, now I will embed some more pixels, okay, on the object to be detected, and that complete image, this complete image is called as it's named as W. Okay, so now this boundary pixels will be then what? W minus X. These are X. Okay, this is the object to be detected in the original image A. So this image is embedded with one more layer of pixels. Okay, and that embedded image is called as W. Now the images, boundary pixels in the embedded image are nothing but W minus X. Okay, so after doing this, you have to perform some operations by making use of erosion and dilation. So first what we need to do is, you have to find out A erosion X. Okay, so X is a complete image. Okay, X is a complete image where this is the object you are required to detect. Okay, so find A erosion X. Okay, when you do A erosion X to A1, to the sub image A1, you get only these 2 points, because it's again a 3 cross 3 structure. It looks like a structuring element, right? So center one, you take it as the origin. So this is 3 cross 3 structuring element. So when you apply A erosion X on this, all these boundaries will be removed, right? Boundary will be eroded. So you will get only this and this. So that's what is shown here. You get only this. When you apply the A erosion X on A2, again this boundary will be removed, this boundary will be removed, all these boundary pixels will be removed. So you get only 1 point. Okay, so this is the first operation you have to perform to detect the object in the sub image in the original image, say capital A. So the first algorithm is A erosion X. Okay, so you got this result. Then after finding A erosion X, then this is the first method. Then there is second one. You have to find out you have to take the complement of A, that is A complement, which has to be eroded with not X now, with W minus X. With the W minus X. So what is the result you get? You have to see. I'll show it in the next slide. Okay, this is the second method in the algorithm. Okay, first step is you have to find A erosion X. Okay, A erosion X, that is done already. Then you have to find out, you have to take the complement. What is A complement? A complement is all the background pixels, right? All the background pixels. Pixels shown in the pink color won't be there in A complement. So all the background pixels are A complement, which has to be eroded with W minus X. W minus X means it is only the boundary pixels. W minus X is only the boundary pixels. So you perform A complement erosion on W minus X. When you do that, you get only one pixel here. Okay, you don't get any pixels in this side, you get only one pixel. You can try. Okay, it's again a set operation, you can try. You will get only this value. Okay, after, so this is done. The third procedure in hit or miss transformation is, once you perform this, once you perform a erosion X, then the second one is you have to perform erosion on a complement and on boundary pixel W minus X. After that, you have to take the intersection of these two outputs of these two steps, that is a erosion X. Okay, this has to be intersected with a complement erosion W minus X. Okay, so when you do that, what is the result you are going to get? So you know the result of a erosion X, you have 2 pixels here and 1 pixel here, right? And when you do a complement erosion W minus X, you get only this pixel. So this pixel is the common pixel between a complement erosion W minus X and a erosion X, because these two pixels are not there in a complement erosion W minus X. So this pixel is there in both a erosion X as well as a complement erosion W minus X. So this is the common pixel. So this is the answer of hit or miss transformation, saying that the image X is found in this location. Center, it will show only the center pixel. So this is a location of the object which we wanted to find or detect in the image A. So this algorithm is very useful to detect the tumors present in various biomedical images. It may be a CT image, maybe a CXR image, MRI image, thermogram image, any images. In case if you want to detect the location of the tumor, then you can apply morphological hit or miss transformation on those images. Okay, so this is about the hit or miss transformation. So I hope you understood the algorithm. So tell me, what is the first step? Nima, can you tell me what is the first step in why hit or miss transformation is used first? Tell me. Anyone? Because if I'm only, yes, tell me. Yeah.
The first step is you have to erode the actual A image with X, ma'am.
What is that?
Position.
X is the image which need to be identified in the original image A, correct? Yeah. So you have
Yes.
to do a erosion X. That's right. Then what we have to do? The second method in the hit or miss transformation. You have.
You have to take the A complement
Mm.
and erode it with W minus X.
Yeah, W minus X is nothing but an embedded image which is called as W. And when you embed the object with the W, you get a boundary that is called as W minus X. So when A complement is eroded with W minus X, you get some pixels, right? Then what you have to do, the third step is you have to find out the common pixels between the first method and the second method. When you find the common pixel, which will give you the details of the object to be detected in the original image A. So as I said, which finds applications in various tumor detections, okay, in biomedical images. So this is about the hit or miss transformation. So hit or miss transformation is mainly used to detect and locate the certain object shapes in an image. So this is the application of hit or miss transformation. I hope it is clear to all. Can you post some messages in the chat whether you understood or not? Hit or miss transformation, or you require me to explain it again? Nikita, Nishita, Nitin D'Souza, whether you understood or not? Hit or miss? Yes, Ligina understood. Nivedita, yes. Because if you don't understand, then there is no point in going forward. That is why. Okay. Okay, understood, right? So this is about hit or miss transformation. So you need not all the time calculate the things. If your structuring element is 3 cross 3, then if it is erosion means which will remove 1 pixel width boundary pixels it will remove, and if it is dilation it will add one extra pixel width, or one it will add the boundary pixels. Okay. So hit or miss transformation is derived from the erosion as well as it's a erosion only everywhere, and you have to find out the intersection, then complements, etc. Okay. So this is about and now the general definition of hit or miss transformation goes like this. You have a structuring element which has two elements, b1 and b2. In the previous example, b1 is x actually, b2 was w minus x. Okay. Then hit or miss transformation of a hit, this star you have to write surrounded by the circle that denotes hit or miss transformation. Okay. With the structuring element b is nothing but a erosion, this is wrong actually, a erosion b1 is actually x. Okay. Which is intersected with a complement erosion b2. So this is the general definition of hit or miss transformation, so which will be normally asked in the exam. They'll ask you to explain the algorithm with examples. Okay. Very important algorithm, hit or miss transformation. I hope you understood. You can take this definition. Okay. You have the structuring element b which is having 2 points, say x and w minus x, you know, right? I've shown you this is x, and then the w minus x is the image boundary. So a hit or miss transformation b is equal to a erosion b1 intersection a complement erosion b2. Okay. So this is the general definition of hit or miss transformation. Some quiz questions you can see. What is morphology? You know what is morphology? It is a biological word which tells about the shapes, objects, right? What are opening and closing operations? I think you know opening. What is opening? Opening. What is closing? Okay, I have given the definition. Show that dilation operation is committed. Actually the properties are not there in your syllabus, so it is actually the dilation is committed, means a dilation b is equal to b dilation a. It's commutative. Since it is not there in the syllabus, I have not taught that. What are the translation? That is also not required for you. What is meant by dilation and erosion are increasing? That is also not required. We have to define hit or miss transformation, that is there in the syllabus. And what is the application of hit or miss transform? So application also I have explained. Okay. So this is about today's lecture. The next lecture we are going to study some of the applications of all this, that is whatever you have studied: dilation, erosion, opening, closing, hit or miss transformation. So by making use of this, what all image processing operations we can perform in image analysis. Okay. Very interesting portion, the next topic. So that I will explain you in the next lecture. Okay. Thank you.